So now at this juncture, we shall continue the sign number and its overflow problem. So we have an overflow problem in sign number operation if the result of an operation and sign numbers is too large for the register and overflow will occur and the programmer must be notified. Kano samanta makaingon nga dako na kaayo ang data for that register. We know that for an 8-bit na microcontroller, we can only accommodate up to 0 up to wait, 0 up to 127. This is for an 8-bit register. But if we accommodate up to 16-bit, this will not overflow kung wala pa sa 127. But it is up to 32,765 rapod kung 16-bit. But as you go along, kung pila ka bit ang imong gamiton, then the extent of overflow mas motaas pod. So the AVR indicates the existence of an error by raising the overflow flag, but it is up to the programmer to take care of the erroneous result. So if ever mula pa siya, maabot siya o 130, sa 130, dira na siya, kini siya, 130, lapas na siya sa 127. So meaning, dito na mo indicate ang V na flag. So meaning nag-overflow na. So erroneous na ang atong result. So let's have an example. So we have here a code and we will be analyzing it and we'll have to check the N and V flags for this code. So first we have this 0x60 loaded to R20 and its equivalent binary is this one, 0110, then 4 ka 0 and its equivalent decimal number is 70. And we also have 0x46 loaded to R21 and this is its binary format or meaning plus 96. So if we add them together, it could be this equivalent sa binary. So plus 96 plus 70 is equal to 166 supposedly. That should be 100, asa na to akong content? So 166. But if we will allow it in our AVR to compute it, it would give us negative 90 decimal. And that is erroneous. That is invalid because our real output is 166 actually. So if we add them together using the binary, we can see that the 7th digit is equal to 1, meaning negative. So n is equal to 1 and since it exceeds 127, we will have our overflow V is equal to 1 and the sum is equal to negative 90 according to our AVR. And it's up to us since this is invalid because we all know that 166 is the correct answer for the decimal. It's up to the programmer to correct this output. So next, we also have when is the V flag set? So there are conditions before ang AVR makaingon nga yes, this is an overflow. So first is there is a carry from the digit 6 to this digit 7 but no carry out of D7, C is equal to 0. So the last digit have no carry, but from digit 6 to D7, na siya carry. And pwede po siya, there is a carry from the last digit D7 but no carry from D6 to 7. So either of these two. It could set to V is equal to 1. If there is carry from D6 to 7 or from D7 out, but not both, either ra sa ilahang duha, then we can set the V flag equal to 1 or set. We have here an example. So we have the 0x60 loaded to register 20, pareho nito sa ganina, and 0x46 loaded to R21. Nag-flag set siya, V is equal to 1, because this is our D6. Our D6, 1 plus 1, have a carry of 1 padong sa D7. So, nasatisfy niya ang first nga condition nga there's a carry from D6 to D7. But, let us check, but no carry out sa D7. As you can see, ang D7, di ba, nag-carry tao from digit 6. 1 plus 1 is equal to 1, 0. Nag-carry siya 1. But, here, sa digit 7, 1 plus 0 plus 0 is equal to 1. Wala siya carry from digit 7. So, nasatisfy niya ang first condition. So, therefore, we can have V is equal to 1. Okay. So, there are also further considerations on the V flag. So, here we have the overflow is possible only when we add two operands when the same sign. So, if different ang ilang sign, there's no overflow possible. And if we add two numbers with the same sign, the result should have the same sign too. And if we add two numbers with the same sign and the result is different, we know that overflow is happening. So, kung same sign, walay overflow. Pero kung different ang iyahang result sa katong gi-add nimo together, then we know that there is an overflow. This is how our CPU decide when to set the overflow. So we have digit 7. So the basis for the CPU to decide when the V flag is set is, first is the V is equal to the digit 7, register D7 ended with the source and the destination register, yung katong first na part, for example, let's say this is the first or the destination value sa digit 7 sa atong register. We have 1 and we also have 1 for the source. And the result of 1 plus 1 is 0, 1, 0. So, added them together and R7 is the result. So, let's say this is D7 and the carry is 1. As you can see, 1 and RD7 is 1, R7 is 1 also. And then them together, yan, nato, and with the inverse of the result. So, unsa inverse sa 0 is 1 gyapon. So, we also have 1 in here. So, 1 ended with 1, ended with 1. And ORing it with RD7 na inverse. So, we have here 0. And ending them with the source 1, invert of that is 0. and the result is 0 also. So 1 ended with 1 is 1, and ORing with 0 ended with 0 and 0 is 0. So the result of ORing this together is 1. So our result is V is equal to 1. So we have here the example. So we have negative 2 loaded to register 20 and negative 5 loaded to R21. And respectively, they have these values for their binary and their hexadecimal counterpart. And adding them together, we have negative 2 plus negative 5 is equal to negative 7 or F9H. This is correct since the first condition sa katong, if they have this the same sign, then the result must have also the same sign. So makarry niya unsa ang iyahang sign. So since the destination and the source have negative sign, the result is negative also. So therefore, our V flag is equal to 0. So V is equal to 0 and still our N flag is equal to 1 since the last digit, the D7, is equal to 1. So sum is negative. Another example is for the positive values for the destination of the register R20. We have 7 and the source is 18. And having these values for this binary and adding them together will result to positive 21. And our N flag is equal to 0 since this is positive. And this is also correct since it satisfies that if two sign numbers having the same sign, having a result of same sign gihapon, then we'll have V is equal to 0. So our V flag is equal to 0 and our N is equal to 0 since the last digit D7 is equal to 0. And we also have here, maragibalik na nato ng example, katong nag-overflow na siya since positive 96 plus 70 is equal to 166. This is overflow since it exceeds 127. And N is equal to 1 since their last digit is equal to 1. And overflow since kung makita po ninyo, the sign, the result of the addition is opposite sa kadtong sign sa gigamit nato nga operands. Okay. And another example is we have 0x80 loaded to R20 and 0xFE loaded to R21. We have negative 128 plus negative 2 is equal to negative 130. Nixid yapon siya. And if we add them together, the CPU will give us 126. That is invalid and erroneous. Mali siya. Because we know for a fact that the result is equal to negative 130. And that's why we have V is equal to 1. Why? Because katong conditions gani sa V flag, ang katong last digit, di ba kani 0 plus 1, wala siya carry. But katong second condition niya, kung ang D7 have a carry, 1 plus 1, 0 na siya carry nga 1, then it will have the V is equal to 1. And N is equal to 0 since the last digit is 0. So, natay overflow. And this is invalid since, as you can see, negative both ang atong operand and the result is opposite. Na siya positive na sign ang result. Okay. And then we also have further considerations for the overflow flag, and that is the programmer must also monitor the status of the carry flag, while for the sign number, that is for unsigned ganina, no? For the sign number, the V flag must be monitored. In AVR instructions such as BRCS, BRCC allow the program to branch right after the addition of unsigned numbers according to the value of the carry flag. Branch is BRCC is branch if C is equal to 0, and this one is branch if carry is equal to 1 is set. Can you clear? So C is equal to 0. Okay. And we also have branch BRVC and BRVS instruction for the V flag allow us to correct the sign number. So we also have this instruction or function nga instruction para makorek ang sign number sa V nga flag. If mali ang katong for example nag-overflow siya ning from siya 1 nya ang result is equal to negative, i-correct niya ang iyang ihatag nga S is equal kung negative ang 1 ang flag, then ang result is negative, ang S is equal to 1. So i-opposite lang niya ang or i-or lang niya ang result sa atong value. We also have BRPL and BRMI for sa N flag. So let's continue for S flag.